In this lesson, we're going to take care of machining the counterbores for the head of our screws in our fixture. You want to make sure that you continue on with the file from the previous example and that your red insertion point is in Setup to Fixture to Toolpath group all the way at the bottom. I also want to make sure that I hide my stock model so I'm only seeing the fixture solid geometry. To machine this geometry, we have several options. We can use some of our dynamic toolpaths, a pocket, or we can use some of our hole making operation. There are various reasons why you would use certain operations over others. For example, if you're doing a circle mill or helical bore operation, there are various parameters such as spring passes and doing multiple depth cuts that can benefit you depending on the end goal of that bore. Now in our specific case, we're simply making clearance for the head of a bolt and it's not a critical dimension. So we're going to simply use our dynamic mill, and the machining region that we want to select is going to be the two areas of our bolts. We can preview the chains and look at the areas that we're going to machine and then say OK. The tool that we're going to use is tool number 12, which is our 1/4 inch square end mill. We're going to call this Machine C-bores. Under cut parameters, we're going to make sure that stock to leave is set to 0. We're going to go ahead and leave all of our default settings. We're going to take a look at our helical motion entry, and we're going to make sure that we use a center point entry. Now when we use our entry options, it's going to select a chain. So if I select Add Chain, I can select these as my entry points and say OK. Under linking parameters, we're going to add 0.25 absolute for our clearance. Our retract is going to be set to 0.1. Our feed plane is going to be set to 0.05. The top of stock is 0, and the depth that we're going to use is based on our contour selection. I'm going to go ahead and use the associative option as well, and make sure that I'm selecting the depth that I want to cut, and say OK. Notice that it's telling me that entry chains are going to be ignored in this case because it's going to automatically start in the center because we have a circular profile. We also notice that we're cutting a little bit too deep, so we want to make sure that we modify the linking parameters and ensure that we're using a depth that's representative of our point. Let's go ahead and regenerate this and take a look at the results. Lastly, that we want to make sure that we create a new stock model. In this case, we're going to be creating a stock model called Setup-2 Fixture-2 3. Remember that we need to make sure that we're using the Setup to stock plane and that we're referencing the last stock model that we created. Our source operation is going to be the last 2D high-speed operation, and we'll allow this to generate. If we go back to our levels and we temporarily hide the fixture setup, we can take a look at the end result. We can see that we've machined the counterbores as well as drilled the holes. They've gone all the way through, and we have the slot directly in the center. Let's go ahead and bring our fixture setup back and fit to screen. In this case, you'll notice that there's a small amount of undersizing that happened on these holes. This sometimes is a good idea when you're making a fixture based on the tolerance of the bolts you're using. To ensure that we have a tighter fit, we could also use countersunk screws or various other methods such as pinning the parts together. In our case, we're going to use the smaller hole to get a tighter fit on the fixture, as well as use the slot to help locate it. At this point in time, I'm going to hide my stock model. I'm going to click on the Setup to Fixture to view sheet to go back to my isometric view. I'm going to save my file so I can move on to the next step.